Have you ever had the experience of standing in the lift and the lift actually goes up, and do you realize that you have the sensation of being heavier, and at other certain times you feel lighter? So this actually depends on the motion of the lift itself. And while you are standing on a scale and both scale and you are inside the elevator, we want to investigate the changes that occur between the normal reaction R. The normal reaction R is actually the can be represented by the scale reading. Okay, so your mg is your weight, okay. So but in all things we should start with using F net equals to ma. But the first thing we want to investigate is if the person is in static motion, okay, and we also know that the lift is in static motion. The lift is not doing any movement yet. So in this case, we have F net equals to ma. So what do we mean by F net? F net is the forces, these two forces, who is greater. Okay, assuming this is going up, but of course this is not going up, but in this case we are talking about upward motion, so I will just assume that R will be greater than mg. But you have to understand that there is actually no motion whatsoever here, so it has to be 0. So because of this, my first reading is actually the weight of the body itself, the weight of the person itself. Let's say the lift is stationary. What's the scale reading? The scale reading, let's say the mass of the person is given as 70 kg. Okay, the lift is stationary, so what should we do? We try with F net equals to ma, and then R minus mg equals 0, and then we have R equals to mg. So the first scale reading should be mg, and in this case we can put 70 times 10. So we have 700 Newton, the usual weight that you felt. Okay, when you step in the lift not moving yet. But once the lift actually moves up with a certain acceleration, but positive acceleration, when we mean positive acceleration, we mean from going from slow or not moving at all to fast. Okay, provided it accelerates uniformly. If it accelerates uniformly. So again, we start with F net equals to ma. Then we have R1 minus mg. I use R1 minus mg instead of mg minus R1 because this is moving up. This is moving up, so I take R1 first. R1 greater than the mg. So that equals to ma. A is a value. Okay, A is a value. A is the value itself, so we can't delete the value. So what happened is we have R1 equals to ma plus mg. So this one collectively I can factorize the m and write a plus g. Do you realize that by putting a together with g, your scale reading actually increased? Because g is 10, let's say a is 5, so 15 times your mass 70. Okay, 15 times 70, that will equals to 1050 Newton. For example, let's say again the person is 70 kg. Okay, so 70 kg, and acceleration going up is actually 5 meters per second. So what we do is you do this again. F net equals to ma, R1 minus mg equals to ma. So R1 equals to ma plus g. So you have a case of 70 and then 5 plus 10. So total you have a value of 1050 Newton. So you actually felt heavier when you go up. When the lift goes up, you felt heavier in the beginning. Okay, but there's also a time where start off with this new page first. There's also a time where after moving fast, the lift actually not accelerating anymore. Okay, let's say this one is going up, but this A is 0, but as there's a velocity constant. There's a constant velocity. So what we do again is F net equals to MA. So we want to know the R4, no R3. All this R1, R2 is not a must. It's just my way of identifying. It can be anything. So in this case, R3 minus mg, when velocity is constant, meaning your father driving a car, the car is neither fast nor slow. It's just flat. You can see it on the meter, the car meter in front of the steering wheel. The speed is the same at, let's say, 90 km per hour. So we have R3 minus mg is ma, but you realize that this is 0 because constant velocity. Because a equals to v minus u over t. If this v is 10 and this u is 10, there's no value to talk about. So we have R3 minus mg equals to 0. So we have R3 equals to mg. So when the lift actually moves with a constant speed, you feel normal again. You feel your weight is the weight that you always felt when you stand on the ground. Okay? So what kind of example can we say? Example question: the lift is moving up. Sometimes they trick you by putting values. It's moving with 2 meters per second. Okay, with velocity 2 meters per second. They just give some value, but sometimes value doesn't have to be used. Okay, so what's the scale reading? So they ask what's the scale reading. So in this case, your understanding is V is constant. So the F net thing is equals to 0 because A is 0. So R minus mg equals 0. So R equals to mg. So when R equals to mg, the scale reading is the same as before. Let's say 70 times 10, 700. So this case of constant velocity is the same as the case of the lift not moving.